This is problem number 2 from section 2.5. In this problem, they say solve the absolute value equation, and they give us the absolute value of 2x minus 4 minus 2 equals 3. So one thing to understand about absolute value equations is you're always going to have two solutions for the most part. There are situations where you have one, but for the most part, you're going to have two solutions. So we can say absolute value equations typically give two solutions. Now, when you go to solve the absolute value equation, you want to isolate the absolute value by itself on one side of the equation. So anything on the outside of the absolute value signs, like the minus 2, we need to move that to the other side of the equation. So the first thing we'll do here is start by adding 2. And we'll get the absolute value of 2x minus 4 equals 5. At this point, this is when we can use the absolute value, our understanding of the absolute value, to essentially write two possible equations. Now we know if the absolute value of what's in here equals 5, then either this 2x minus 4 is going to have to produce a 5, right? Because the absolute value, we know the absolute value of 5 is 5. But we also know the absolute value of negative 5 is also 5. So 2x minus 4 is going to have to produce a 5 inside there to get it to equal 5. Or it's going to have to produce a negative 5 inside the absolute value sign to get a 5 on the outside equal 5. So this idea right here, I'm going to circle it. This is the big idea. This is the big idea because now we know that 2x minus 4 has to equal 5, or 2x minus 4 has to equal negative 5. So at this point, we want to set up two equations. Okay. Our first equation is, what if 2x minus 4 equals 5? That's coming from this portion, right? Absolute value of 5 is 5. So 2x minus 4 could equal 5 inside there. Or 2x minus 4 could equal negative 5. So when you take the equation that's inside, the expression that's inside the absolute value, and you write two equations, you're essentially taking care of the absolute value signs, right? That's you're interpreting the absolute value signs, so you don't need them anymore. But if you don't write the two equations, you can't do anything with this problem. Like, you can't just solve it. You won't get any answers by solving. I kind of always think of the absolute value signs like brick walls. Like, until you evaluate them and interpret what they mean, there's nothing you can really do there. So once you set up your two equations, you can solve. So we're going to add 4 to this side. So we get 2x equal 9. Divide by 2 and x equals 9 over 2. Or we can add 4. And we get 2x equal negative 1. Divide by 2 and x equals negative 1/2. Okay. At this point, I think it's important to circle our answers, number 1. And number 2, check them. Well, let's see if it even makes sense. Let's go back to the original equation. Now, 9 over 2 is 4.5. Okay, so this is 4.5. So I can say 4.5 times 2 is 9. 9 minus 4 is 5. Absolute value of 5 is 5. 5 minus 2 is 3. So that works. Plug in the negative 1/2. Negative 1/2 times 2 is negative 1. Negative 1 minus 4 is negative 5. See how we get the negative 5 inside the absolute value signs? Absolute value of negative 5 we know is 5. They say that right there. So then we have 5 minus 2, which is 3. So both of these are solutions. And that's how you check your answer.